Okay, here's the notes on adding and subtracting radicals. Broken down for you in steps. Step 1 is simplify all the radicals. Identify the radicals with the same index and same radicand. Remember, index is that little number in front of the radical sign. Radicand is the number inside. These are the only ones that can be combined. We're going to treat them as like terms. Okay, for common radicals, add and subtract the like terms, and subtract the coefficient, and keep the common radical the same, and so the radicand and the index the same. So let's do the first example here, the square root of 27. So step 1, we want to simplify those radicals. So I will get 3 times square root of 4 times, no, square root of 9 times square root of 3 minus 2 times square root of 4 times square root of 3. So I want to simplify these first. Square root of 9 is 3. So 3 times 3 is 9 root 3 minus square root of 4 is 2. 2 times 2 is 4. 4 root 3. So as you can see, now I have the same radical sign within both of, or the same radicand within both of these, same index to the 2. And I'm going to treat these as like terms. So if I follow these steps, add and subtract the coefficient and keep the radical sign and the number inside. So 9 minus 4 is 5. Keep the root 3. Let's try number 2, because now we have a cubed root. With a cubed root of 54, I want to break down. So that's going to be 3 times cubed root of 27 times cubed root of 2 minus 2 cubed root of 2. Well, I can see that those will be able to be combined most likely. And cubed root of negative 16, which is going to be negative 8. That's plus negative 8 cubed root times cubed root of 2. We want to simplify all these down. Cubed root of 3 is 3. 3 times 3 is 9. 9 cubed root 2. Took care of that part. Now I'll take care of the middle term. Minus 2 cubed root 2. Cannot simplify that anymore. Plus negative cubed root of 8 is negative 2. Negative 2 times 7 is negative 14. Cubed root 2. So all of my indexes are the same, all of the radicands are the same, these are all like terms. So I'm going to add and subtract the coefficients. 9 minus 2 is 7. 7 plus a negative 14 would be negative 7 cubed root 2. Let's do one more. So now we're going to do perfect fourth root of 48. Perfect fourth root would be 16. And that's going to be 7 times fourth root is 16 times fourth root of 3. And minus 2 fourth root 3 plus 3 third root 27, and or I mean 72, sorry about that. And 72 we can break down to be 8 times 9. 8 times third root 9. Alright, let's break it down. 7 times 4 is 28. Fourth root 3 minus 2, fourth root 3. Simplify this one down. Third root of 8 is 2. 3 times 2 is 6. Third root 9. Now, different radicand, different index, these are not like terms. These cannot be combined together. But these two can. Same radicand, same index. So I'm going to subtract the coefficients, keep the index and the radicand, and then just leave the last term tagged on. All right. Next part. I want you to try number 4 on your own. Number 5. Now we're bringing variables into the picture. So again, we must have the same radicand, same number inside, and same index. So square root of 98 can be broken down to 49 times 2. Square root of 49 times square root 2 times square root of x to the 4th y to the 2nd minus 3x squared y root 2. So the square root of 49 is 7. Can't simplify the square root of 2 anymore. Okay, as for the variables, I have two groups of x squareds within here and one group of y squared. Times square root 2 minus 3x squared y square root 2. Now my variables are the same power. Radicand is the same index, so these are like terms. I can subtract the coefficients. And as we did before, I'm not going to change the powers on the variable. The radical stays. Now if these were not the same, like if this was square root 3, I could not combine these. If this was a y squared, I could not combine these. Alright, so multiplying radicals together. Let's read the instructions. Step 1, multiply the coefficients, then use the product rule, and I multiply the index together. Simplify the results. Okay, so I'm going to multiply a, or let's give you the rule here. So you will keep the index the same. You're going to multiply a times b. So, sorry, not multiply the index, multiply the radicand. So 27 times 5, you get 135. Now I want to simplify this, and a perfect square that goes into 135 is 9. Square root of 9 times square root of 15. Square root of 9 would be 3 root 15. And the same here, multiply the coefficients. Negative 6, multiply the radicands. I'll get 180. This is a negative 6 because that is a negative 2. And let's break down 180. A perfect square that goes into 180 is 36. And 5. Square root of 36 is 6, so negative 36. 6 times negative 6 is negative 36 root 5. Alright. Cubed roots, so I'm going to keep the index the same, multiply the coefficients, multiply the radicands, negative 216. Negative 216 happens to be a perfect cube root. My answer will have to come out negative. 10 times negative 6 is negative 60. Okay, I want you to try number 10 on your own here with the fourth root, and then we'll finish the rest in class tomorrow.